Today we'll try to study about a concept called motion of a boat in a river. We'll try to study a concept related to swimmer and a river and motion of a boat in a river. All these are related concepts. So let us try to study about motion of a boat in a river. Motion of a boat in a river. Motion of a boat in a river. So see now, when we try to study about motion of a boat in a river, we should understand that how the water is flowing. Depending upon the flow of water only, the amount of force the particular boat has to apply in order to move on the flowing water. If you don't know what is the force of the water, we cannot apply the force in order to move with the along the river or against the flow of the river. So that's why here we will be studying about three important concepts or three important terms. It means that the motion of a boat in a river is been categorized into three different categories. You can categorize into three different types. So now your problem can be, or the numericals on this concept can be in three different ways. So the first one will be, the first kind of category will be upstream. Upstream, and second category will be downstream, and third category will be the general approach. The general approach which we use to find it out the some terminologies regarding the motion of a boat in a river. So see here, when you talk about upstream, upstream means if you if this is my river and the flow of water, this is the flow of water, let the flow of water is in this direction. If the flow of water is in this direction and if the boat is traveling, in this direction, we call it as an upstream motion. Upstream motion means if this is the velocity of the river which is traveling or the water is flowing from left to right, then if the boat is traveling against the flow of water, if the boat is moving against the flow of water, it means that the motion of a boat is in upstream motion. So we can say this is against the flow of water, against the flow of water. If a boat is traveling against the flow of water, we call it as an upstream motion of a particular boat. Now coming to the next one, downstream. When you talk about the downstream, if this is a flow of water, velocity of the water, and even the boat is traveling in the same direction, then we can say that since both this velocity of the water and also the boat both are moving in the same direction, we call it as a downstream motion. So it is like both water and boat in same direction. If this both are in same direction, we call this kind of motion as a downstream motion. So these are very two important concepts, and later we will be studying about the general approach, just as the one which you have seen even in the motion of a swimmer or the swimmer and the river problem. Even in that swimmer and river concept, we have seen one approach that is called as a general approach. So now here in this particular motion of a boat in a river, we will be seeing about three different concepts. First one is upstream motion, downstream motion, and general approach of a particular boat. We will be studying about the upstream motion of a boat. Upstream motion of a boat. So now let us consider that VBR is the velocity of a boat. Let us consider this terms like VBR is it is a velocity of the boat in river. It is a velocity of the boat in river, or else simply you can say it as velocity of a boat with respect to river. And again VR is the velocity of the river, So see now, whenever your river is flowing in one direction and your boat is traveling in other direction, we know that the motion of these two particular bodies, one is water and the other one is a boat, both are in opposite direction. Both are in opposite direction means I can say that the angle between these two is equal to 180 degrees. Always the angle between the upstream motion of a boat, the angle is equal to 180 degrees. Why? Because both are traveling along the straight line, and definitely they are in opposite directions to their motion, so the angle will be 180 degrees. Now we are supposed to calculate what is the resultant velocity of this particular boat with respect to this velocity of water. Then we know that, see now, let me assume that the water is flowing at a 8 kilometers per hour, and the boat is traveling against the flow of water at 16 kilometers per hour. And if I want to find it out, what is the actual or the resultant or the net velocity of the particular boat, then what I'll be doing, both are in opposite direction. Definitely if I take a difference of these two, I'll be getting the actual velocity of the boat. So that will be like 16 is for the boat and 8 is for the water. The actual velocity of the boat traveling against the flow of water will be 8 kilometers per hour. 16 minus 8, it becomes 8 kilometers per hour. So in the same way here, the resultant velocity of boat, is been given by V is equal to VBR minus VR. Since both are opposite directions, so the negative sign comes into picture. So V is equal to VBR minus R. Then next one, the time taken by the boat to travel from one point to another point, travel from one end of the river to other end of the river, to travel in river. So that has been given by, we know that time T is equal to D over V, where D is nothing else but it's the distance between the two banks of the river. Then this becomes as, this implies the time taken will be D over V. What is V? V is the resultant velocity. So it becomes VBR minus VR. So this will be the amount of time taken by the boat in order to travel from one bank A to bank B against the flow of water. So that is T is equal to D over VBR minus VR. So these are the two important formulae related to the upstream motion of a boat in a river. For this one, I'll try to name it as, since it's going in an upstream motion, I'll take it as TU. You'll come to know why did I notate it as a TU in the next phase of this concept. Let's see the second category of the motion of a boat in a river. The second category is what? Downstream. It means what here? If this is the river and the water is flowing in this direction, this is the velocity of the water, and this is a bank A and bank B. If a particular boat has to travel from one bank to another bank, let this be the distance between the two banks of the river, and this is my boat here, and even the boat is also in the same direction just as a river. So let this VBR be the velocity of the boat. Okay, so see now, since my boat is traveling in the same direction as the water is flowing in the river, definitely what happens, the entire resultant velocity of this boat will be like an it's a summation of the velocity of the boat plus also the velocity of the river. Why? Because if water is flowing in this particular direction, and if you are also moving the same direction, definitely the velocity of water also helps us to go very fastly in the same direction. But whenever we are going against the flow of water, we are supposed to apply more force to go against the flow of water. But here what is happening here? My boat is traveling in the same direction as the direction of water, so both are having the same directional velocity. So because of that one, the resultant velocity of the boat becomes the velocity of the boat plus the velocity of the water. So we can, and we know that since it is downstream, the theta is equal to 0 degrees. Because see, both are on the straight line motion, and both are parallel to each other, and both are also in the same direction. So therefore the angle between these two river flow, water in the river flow, and also boat direction, both will be having an angle of 0 degrees. So now here the resultant velocity, the resultant velocity of boat, the resultant velocity of boat is given by V is equal to, it's a summation of VBR plus VR. It's a summation of VBR plus VR. So it becomes VBR plus VR. This is the resultant velocity of a particular boat moving in a downstream motion. So next one, then second one, the time taken by boat to travel from one end of the bank to another end of the bank. It is given by T is equal to D over velocity. This implies T is equal to D is the distance between the two banks, and velocity is nothing else but the resultant velocity, that is VBR plus VR. Since we are talking about the time of a boat which is traveling in a downstream motion, I will notate it as TD. The time taken by the boat to go downstream is given by T down is equal to D over VBR plus VR. So this is the formula which we have seen for downstream. So now in the same way, the time taken by boat to go upstream is given by TU is equal to D over VBR minus VR. So we have seen this VBR plus VR and VBR minus VR in the upstream and downstream concept. So now let us see now the ratio of these two. The ratio of, so this will be the third one now. The ratio of time taken by boat to go downstream to the time taken by boat to go upstream. So this formula is very important. So it is given by, you can see here now, let me consider it as 1 and 2. So it will be 1 over 2. So it is 1 over 2, that is, if I do the division of this two equation, you will get TD over TU, that is equal to D over VBR plus VR over D over VBR minus VR. So now if you do the mathematics over here, ultimately you will get a formula such a way that it will be VBR minus VR over VBR plus VR. So this will be the time taken by a particular boat to go downstream to upstream. So it is a ratio for the finding out the time taken by a boat to go downstream and then come back on the upstream motion. So this is very important formula. Let us see the fourth one regarding the ratio. The ratio of time taken by the boat to go, this one is regarding the downstream, so it will be now upstream to go upstream first, then to the time taken by boat to go downstream. is given by. So see now, it is nothing else but we will be doing now here in the previous equations 2 over 1, that is upstream to downstream time ratios. So it will be d over, for upstream it is what, d over VBR minus VR, divided by, for downstream it is d over VBR plus VR, so it is d over VBR plus VR. So this is equal to, if you do the mathematics over here, you will come up with a formula VBR plus VR over VBR minus VR, that is equal to upstream to downstream. So this is the formula for the ratio of time taken by a boat from first to the upstream and then to the downstream. So these are very important formulae regarding to solve the numericals in a concept of motion of a boat in a plane. So these are very important formula. Now we will try to see what will be the total amount of time taken by the boat. It means that actually I am trying to tell about some numericals where they can ask even in such a way that what is the time taken by the boat or a swimmer. It is both related numericals. This formula are related to both to the swimmer and also boat. If a particular swimmer goes down the stream for some amount of time and again comes back the same distance, then what is the total amount of time? If this is a kind of question, then we are supposed to apply this formula which we are going to study now. Then the fifth one will be the time taken by boat or swimmer if boat or swimmer goes downstream for d distance and comes back is. It means that a boat is traveling, a boat or a particular swimmer is going down the stream along the velocity of the water, and let the distance he has traveled is d. Then again if he is coming back the same amount of distance, then what will be the total amount of time? For that one, what you are supposed to do? You are supposed to apply the amount of time, you are supposed to calculate what is the amount of time taken by a particular person. If a particular person is going down the stream and again coming back, let the amount of time taken by the person to go down the stream, it is like TD, and the amount of time taken by the person to go up the stream or come up the stream is equal to TU. Then the total amount of time, total time T is equal to down the stream plus up the stream. This becomes the total amount of time. This formula you are supposed to apply. In the previous case, we have applied that, we have calculated the ratios of the two different times, but here we are trying to calculate the total time. Total time T is equal to, what is TD? TD is equal to down the stream. Down the stream formula is the distance d over velocity. What is the net velocity? For down the stream, it is going along with the water, it will be VBR plus VR plus up the stream, the distance d over net velocity, that is coming up the stream, means it is coming against the flow of water, VBR minus VR. So this will be the total amount of time traveled by a particular person or else the boat down the stream and again coming back in the same distance. So this 5 formula is very important regarding the up the stream and also down the stream numericals.